The next thing that I'd like to talk about is homework 5. But in order to get there, first I have to talk a little bit about what comes after that, which is challenge 1. Homework 5 is basically like the first 20% of what you need to get done for challenge 1. So homework 5 makes sense in the context of challenge 1 coming up next. In challenge 1, you're going to be building a Unix shell like bash. Yours is going to be called nush. And what a shell does is it's going to read one line, which is a shell command, normally typed in by the user, and then it's going to execute that command, and then it's going to repeat that. And in order to execute the command, we have to have some idea of what the different possible commands are. And there's various different things that shells do with those commands. The most basic thing that a shell does is it's going to run a program. So when I say echo hi, what this generally means is that it's going to try to find a program called echo. It's going to run that program with one user command line argument, hi. If I run a program like cat unix.c, it's going to try to find a program called cat. It's going to run that with one argument unix.c, and then the cat program is what's going to do this like printing out of text from the file to standard output. Now, in addition to being able to just run commands with arguments, we also have operators. So for example, there's a command called tack, where if I type in 1, 2, 3, 4, and then I'm going to press Control D to send an end of file to this command, this program, it's going to print out its lines of input in reverse order. It's like cat, but backwards. Now, if I say tack, and then instead of having it read from standard input, I tell it to redirect I tell the shell to redirect the file, what was this file called? Unix.c, to become the standard input of the tack command. We're going to go ahead and get the lines of text from Unix.c printed to the screen in reverse order. The program tack is doing the reversing and printing to the screen, but it is the shell that's responsible for opening up this Unix.c file and causing tack to see the contents of that file as coming in over standard input. So this operator, shells have some operators, this operator is called redirect in. If we say tack and then say greater than, we say output.text, and then we say 1, 2, 3, 4, and then type Control D to send end of file, nothing prints to the screen. There's just the 4 lines of text that we input. But if we then look in output.text, we find those 4 lines in reverse order in that file. And that's because this operator here, redirect output, causes the shell to take whatever output was produced by this command, and instead of printing it to the screen, standard output becomes this file, and it creates that file as a place to put the data that comes out of it. This command, this program, prints to standard output. We have a so if we say if we say cat output.text, then the cat command is going to read the file and print it to the screen. But instead of printing it to the screen, we can go ahead and say instead we want to take the output of the cat command and pipe it to become the standard input of the tack command. So now we're going to run the cat command, which will read in output.text, print it to its standard output. Its standard output becomes the standard input of the tack command, which then is going to print those lines in reverse order, which gets us back into forward order. to the screen. So another operator is pipe, and that plumbing of taking the standard output of one command and making it the standard input of another command is something that the shell is able to do. We have, so the sleep command is going to just wait for some number of seconds before terminating. If we say sleep semicolon echo high, what semicolon is the sort of command separator. So it waits for the first it waits for the first command to finish before it runs the second command. So not until the sleep program terminates after 3 seconds do we echo high. But another thing that we can do is we can run commands in the background. So if we sleep 3 in the background, it's going to immediately return, and bash is going to print out this little bit of job control information to say that this is job 1, the sleep command, it had process ID 27682, it's now running in the background. And then if I just go ahead and tell bash that I'm paying attention again, it's going to say that that job 1 finished, and the job 1 was the sleep 3 command. So this is the background operator. The background operator can also be used in a 2-argument form, where first we do the command on the left in the background, then we're going to immediately do the command on the right. So it's going to say hi, and then after 3 seconds, we'll get that sleep 3 command had finished. Now, another pair of operators that we have are the AND and OR operators. The way those work is every program that we run has an exit code. So for example, if I say echo hi, and then I print out $? Which is a special shell variable that's handled by bash, that's going to tell us what the exit status of the previous program that was run is, and 0 means success. There's a command called true that all it does is exits with a successful status. There's another command called false, and all false does is it's going to exit with a status of 1, which is failure. So that lets us use AND and OR short-circuiting operators to control, to both operate as sort of Boolean logic operators, but also as sort of flow control operators. So if we say true and echo hi, that's going to print hi. And the mechanic here is that first it's going to run the command on the left, and if that command is successful, then it runs the command on the right. If I instead say false and echo hi, it's not going to do anything, because false and anything is false, so we get this short-circuiting behavior where if we say false and another command, it knows whether the result of that is success or failure just by running the first command, because it failed, and false is still false. False and anything is false. On the other hand, we also have logical OR, Boolean OR. We have OR, which will say we only run the command on the right if the command on the left failed. So false, but if that fails, echo hi. True, but if that fails, echo hi. So those are a couple more shell operators. And that is the second set of 7 shell operators that you'll have to handle for your shell assignment, challenge 1. Now that brings us to homework 5, where you don't actually have to execute shell programs or shell commands. All you have to do is take a shell command, and you have to turn it into a series of tokens, which can then be used later to be an input to executing a command. And so if we go ahead and look at a command like echo1 semicolon echo2, that's 5 tokens. The 5 tokens are echo1 semicolon echo 2. And in this homework 5, what you're supposed to do is you're supposed to take an input. You're supposed to read a line of text. Then you're supposed to split that line of text into tokens. You're supposed to store the sequence of tokens in a data structure, like a vector or a linked list. Then you need to print them out in reverse order. So here the tokens were echo 1 semicolon echo 2. So we printed them out in reverse order, 2 echo semicolon 1 echo. And you'll note that shell tokens are not necessarily separated by spaces. A command and its argument are separated by spaces, but the semicolon doesn't have a space before it. So you're going to have to be able to handle that. Here's another example. Sort foo.text pipe to unique. Unique is the last token, pipe is the next token, sort foo. Now to see what all of the things that you're going to have to get to work are, we can go ahead and take a quick look at the tests for homework 5. So if I head over to, you know what, let's head over to homework 5. This is 3650, this is homework 5. So if we go ahead and look in the starter code, we can see that we have a script test.pl. And what the test.pl script is going to do is it's going to look in the test directory for files with a sh extension. It's then going to run each one of those things. It's going to use redirect input so that it looks to your program like the text content of that file is coming in on standard input. But the mechanics are slightly different than typing, so this can expose some bugs with your input handling. But in any case, let's go ahead and look in here in the test directory. So test 1 is just echo hello, and there's a corresponding out file that says we expect the tokens to be echo, then hello. That makes sense. Things get a little bit more complicated. 07 sort pipe.sh. So if we have sort test sample.text pipe to tail-n2, that's going to give us those tokens in reverse order, r2-n tail, etc. So the first 11 tests or so are reasonably straightforward. I don't know if 11 is really straightforward. Let's go ahead and look at 11. Yeah, the first 11 are reasonably straightforward, and then the 12th is a little bit trickier. You can see here that we have no space here after true. Then we have multiple spaces. We've got a pipe over here with no spaces on either side. So you just want to make sure that you parse this the same way, or you tokenize this the same way that Bash would, and the result will be that you get that series of tokens in that order. And that should be reasonably straightforward to figure it out, although it's called tricks because it is a little bit tricky. So that's homework 5, and good luck on homework 5.